So conic sections. Tell me how much background you guys have in doing circles, ellipse, hyperbola, parabola. I need to have just some background for me. That'll affect how I teach a little bit. Have you done it at all? You've never graphed a circle or an ellipse or a hyperbola. But you didn't get into much else. Okay. Well, then this chapter is going to be really important. And I'll make sure I push you a little bit. We're going to start out this chapter, though. We're not going to jump into circles, ellipse, hyperbolas. Instead, we're going to start out this section. If you look at 6.1, we're going to do the dreaded P word. Proofs. But they're not the type of proofs that you're familiar with doing. They're easier. You don't have to write down reasons for everything. We're going to do coordinate proofs. So before we jump into doing too much on coordinate proofs, we got to talk in general about some stuff on how or what we're going to do when we do these proofs. And then I think the best way is for us to do a bunch together. Okay? So we need to know about these things. I think you better know about distance formula. Because you're going to have to prove that something is the same length as something else. We have background on distance formula, right? So the distance is x sub 2 minus x sub 1 plus y sub 2 minus y sub 1 squared, distance formula. We probably better know midpoint, midpoint, big M, we say, well, we average our x's, and we average our y's. We better know what it means to be parallel, because we might have to prove that it's a parallelogram. So if you're going to prove something is a parallelogram, you better know that two sides are parallel. So slope 1 equals slope 2. We better be able to prove that maybe something is a rectangle. So if we're proving something's a rectangle, we better understand perpendicular lines. And if we're talking about perpendicular lines, we know that slope 1 multiplied by slope 2 will equal a negative 1. They are opposite reciprocals of each other. That's what we say. But to show it, you need to show that if you multiply the two proofs, you would get negative 1. I guess in general, we need to know what slope is, but I probably won't write that down. Maybe we should talk a little bit more, maybe some geometry stuff. I mean, we need to know, if you're asked to prove that something is an isosceles trapezoid, do you know what an isosceles trapezoid is? I mean, if we're going to be asked to prove something that is isosceles trapezoid, well, if you have an isosceles trapezoid, you know that maybe just in general what it means to be a trapezoid, you'd have to prove that these two sides are parallel to one another, that they have the same slope. You'd have to prove that these two are not parallel to each other, and that they're equal in length if it's an isosceles trapezoid. If you wanted to prove something is a parallelogram, you guys know a parallelogram is just a rectangle that a fat guy leaned on? Right? A parallelogram, opposite sides are parallel, and opposite sides are also equal in length. How about a rhombus? Do you know what a rhombus is? They're going to come up. It's a diamond. So what's the difference between a rhombus and a square? A rhombus has all four sides being the same. So does a square. But a square also has all of the angles meeting at 90 degrees. A rhombus, not necessarily. We'll talk about the diagonals. So you better be familiar with the word diagonals of a rectangle, or diagonals of a trapezoid. Connect vertices that aren't consecutive. That would be a diagonal. Could have to talk about the difference, or they might say the median of a triangle. How about the median versus the altitude? All this geometry talk. Where does the median go on a triangle, let's say? So if I drew a triangle, let's do this type of triangle, and I'm talking about this, where does the median go? To the other side. The median goes to the midpoint, so those two pieces are equal. A median goes to the midpoint, and altitude is dropped so that it meets the other side at 90 degrees. Okay? And all of these things that we're going to do it in the coordinate system. That's why they're called coordinate proofs. So everything we do, we're going to draw a picture in an XY axis, and from there we're going to go to work. So I think sometimes the hardest part is drawing the picture. So if I have an XY axis and they ask you to put to prove diagonals of a rectangle are congruent. The diagonals are congruent. I'm going to draw a rectangle in here. I usually like quadrant 1 personally. I would call this 0, 0. I might call this 0A. I might call this B0. Then what do I have to call this? I don't want to keep making up names. I have to call that, the x coordinate is B, the y coordinate is A. Half of the problem is drawing the picture the right way. And again, I kind of like quadrant 1. If I were going to draw, let's say you are given an isosceles triangle, you might draw an isosceles triangle like this, so you know that this side equals this side, but I would probably call this 2A0. If I called that 2A0, what would I have to call this point up here? At least one of the coordinates, what would I have to call? I'd have to call that A, and then this would have to be whatever we make up. I would probably call it B. And then they might ask us to prove something that maybe all of the medians meet at a point. I don't know what they're going to ask us to prove. That's what we're going to get to in just a second. So if I do that median and that median and that median, do they all meet at a point? And you know that there's also a relationship about third and 2/3. Some background on geometry. Let's look in the book really quick. I'm not going to do the examples that are in the book, but they show, oh, I probably should do one more. I think that would be good. If you are given a parallelogram, I'd probably draw something like this if I'm in quadrant 1. But how you name it kind of becomes important. You don't want to just keep making up letters. That one's obviously 0, 0. This one, maybe I call this one A, B. If I call this one C0, then what would I have to call this one? I don't want to keep making up letters. So the question I'm asking then is, how far is that distance right there? This distance is C, and this distance from here to here is A, so that is A, so this is C plus A. And then the y coordinate, of course, has to be B. So how you draw the picture to start with, I think, is the hardest part. So, again, I will let you look through some of the examples that are in the book. Let's just review really quick, page 217, summary of methods commonly used in coordinate proofs. Number 1, to prove line segments are equal, use the distance formula to show that they have the same length. Number 2, to prove non-vertical lines parallel, show that they have the same slope. Number 3, to prove lines are perpendicular, show that the product of their slopes is -1. Number 4, to prove that two line segments bisect each other, use the midpoint formula to show that the segment has the same midpoint. So if you want to show that they bisect each other, show that they share the common midpoint. Number 5, to show that lines are concurrent, show that their equations have a common solution. Let's do some problems. So here's our homework on page 218, and that's how I'm going to continue to teach. On page 218, we're going to do these problems. We're going to do 1, 3, 4, 6, 7, 10, and 12. That's our assignment on 6.1. So let's see how many we can get done together. If you guys don't mind listening to me for about 25 minutes, let's do our homework together. Okay? So let's start with number 1. Number 1 says, use figure A or C of class exercise 1 to prove that the medians to the legs of an isosceles triangle are equal. The medians to the legs. So we get to use picture either A or C for an isosceles triangle. I would choose the one that's all in quadrant 1. So I'm going to choose my picture like this. Your picture is a big part of your proof. So when you label your picture, the person that's grading it is familiar with your picture and is looking at your picture. That's how they labeled the one, isn't it? We use the one. Yeah. So here's my proof. So I'm going to name this thing, I'll go this way, ABC. So I say, here's what I am given, just like you did back in your other proofs. Write down what's given. I'm given isosceles triangle ABC. And then I would probably label my picture so I know that this is an isosceles triangle. We are asked to prove what? Medians to the legs are equal. I'll write it out in words. Medians to legs are equal. But now I'm going to write it down in symbols. So i.e., that is what I'm trying to prove. We better talk first. Now, what are the legs? What are the legs in isosceles triangle? That's not a great looking isosceles triangle. It looks kind of like equilateral, but it's isosceles. I didn't say that the other side is equal. But what are the legs on an isosceles triangle? The two sides that are equal. That's my legs. So I'm supposed to prove that the medians are equal. Remember, the median is going to go to the midpoint. So in terms of my picture, here's what I'm trying to show. I'm going to call this M, and I'm going to call this N. I need to prove that AM equals CN. All right. So kind of here's my proof. Let's label this because M is my midpoint. So I'm going to mark it that that side equals that side. If M is my midpoint, and I could maybe make a note of that here. M is midpoint of BC, and N is midpoint of AB. Part of my proof is my picture, so let's write down what are the coordinates of M, the midpoint. You add your x's, divide by 2. So a plus 2a is 3a divided by 2. Add your b's and divide by 2, and you get b over 2. Your n, add your x's. I didn't label this one. This is 0, 0. A plus 0 is a over 2, and b plus 0 is b over 2. So I need to prove that those two distances are equal. So AM, what's the distance from A to M? Well, it's going to be the square root of x sub 2 minus x sub 1, so that's 3a over 2, the quantity squared, plus, changing my y's, y sub 2 minus 0, that'd be y over 2, the quantity squared. I'll go another step and kind of clean this up a little bit. This would be 9a plus 9a squared. What did I write right here? I can't read my writing. That's supposed to be a b, isn't it? B squared. And this is all over 4, and the square root of 4 is 2. Square root of fractions, you do the square root of top, square root of bottom. Kind of nod your head if you're with me. I know this is kind of deep for a Friday, but hang in there. The second one's going to work out nice, I hope. So let's find out what is Cn. Cn is the square root of, change in your x's. So I'll do it this time. 2a minus a over 2. I'm going to square that. Plus 0 minus b over 2, the quantity squared. What's 2a minus a over 2? What's 2 minus a half? 3a over 2 quantity squared, plus this is negative b over 2 quantity squared, and you square root that. I think we can all jump to the fact that that's 9a squared plus b squared square root all over square root of 4, which is 2. And how does this right here compare to this right here? And if they're equal, that's we proved what we wanted to prove. We just proved that this, A to M equals C to M. So we conclude our proof by saying somewhere, where's my page extender? Therefore, the medians to the legs of an isosceles triangle are equal. The medians to the legs of an isosceles triangle are equal. That's our proof. Now you can also kind of see why the assignment isn't 25 problems. But that's what coordinate proofs kind of look like. You put it in the coordinate system. Your picture is a big part of your proof. Are you ready to do the second one? What's the second one that I assigned? Can you read? Can everybody read it? Okay, let's jump to number 3. Number 3 says, prove that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and has a length that's half of the third side. Okay? So, I need a picture of a triangle. Didn't say anything special about this triangle. So on purpose, I don't want to make it look equilateral or isosceles. I just want to make a random triangle. So I'm just going to make my triangle look like this. So I'm going to call this triangle ABC. It is important because it's a coordinate proof. We need to give labels to our points. So I'm going to label this one 0, 0. I'm going to label this one A, B. And I'm going to label this one, well, because it's just any random triangle, I'm going to label that one C, 0. I'm going to go back and read again to make sure I didn't read anything wrong. Prove that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and has length half of the third side. Okay.
Excuse me, Rachel Hydorn and Abby Keeper, Hannah Nelson to the office, please.
So given triangle ABC, I'm also given that M is midpoint of BC and N is midpoint of AB. So I'm going to label that. So here's M. And I know that's a midpoint, so I'm just going to identify that those two sides are equal because it's a midpoint. And I'm going to identify this one as N right here, and I know that those are equal. So what are we asked to prove, you guys? Two things. And we can write it in symbols. What's one thing I'm asked to prove? There's two things, but what's one of them? In symbols from my picture. Two sides are parallel. In symbols, what am I asking? Which two sides are parallel? N, M, aren't we? Huh? The line segment joining the midpoints, that would be this line right here. We're supposed to prove that that is parallel to AC. And let's just write down the second thing that we're supposed to prove. And then we'll prove it. But I think it's good to write it down in terms of symbols. What's the second thing we're asked to prove?
That is half the length of AC.
So NM equals half of AC. And we can do that for lengths of segments, right? Geometry class people. Been a long time since I've taught geometry, but that means the segment length, right? NM? You guys are okay with that? I'm okay with it if you're okay with it. All right, so let's find out slope. What's the slope of NM? We didn't label these points, my bad. Let's label these points. I just put them on here. Let's label them. What is the ordered pair for M? How do you do it? You add your x's and divide by 2. A plus C divided by 2, B divided by 2. Over here, A over 2 and B over 2. So the slope of MN, well, I don't like my notation on that. How can I write that? Slope of NM would be change in y over change in x, right? Change in y over change in x. So this is 0 over who cares, which is 0. Why is it 0? Change in x, or excuse me, change in y, b over 2 minus b over 2. B over 2 minus b over 2 is 0. 0 over who cares is 0. I didn't find out the who cares part, but I don't really care. M, the slope of AC, would be, well, 0 over who cares, in this case it's C, is 0. Did we just prove that they're parallel? Yeah. So there's really, I should write down, here's my proof. There's the first part. What's the second part of my proof? I got to find the distance. I got to find the distance. All right, so what is the distance of AC? Well, it's a square root using that formula. Change in x, c minus 0 is c squared. 0 squared. Square root of c squared is c. And I guess you probably could have come up with that without the distance formula, right? I mean, how far is it from here to here? Well, it's c. How about the distance of NM? This one doesn't look so friendly. What's a plus c over 2 minus a over 2? C over 2 squared plus b over 2 minus b over 2 is 0 squared. So this is the square root of c over 2, which would be c over 2 squared. Square root of that would be c over 2. Tell me about those. Is it half? Awesome. Therefore, now you can write it in words. What am I going to write? Therefore, line segment joining the midpoints of two sides of a triangle are parallel to third side and half of the length. Okay? Now you know why we're doing some of these together, right? I'm not just going to throw this on you guys. And please understand, the whole chapter is not like this. This is the only section that's like this, but we need to do a little bit of it. So we're doing it today. What's the next one we're going to do? And some are shorter than others. 4 says, I'm going to, we'll set it up, but I want to make sure we can get to the rest or talk about them. Number 4 says, use figure A or B of class exercise 2 to prove that the diagonals of a parallelogram bisect each other. Let's set it up. Number 4. So you are given parallelogram. Oh, what am I doing? You're given parallelogram ABCD. So I need to sketch it on here. Personally, this is the type of parallelogram that I like to use. So I think that's what I'd recommend you use as well. So ABCD, I don't know if they named it the same way, but 0, 0. It doesn't really matter, I guess, but I could use the same notation as what I used before. This one was C, 0. So then this one had to be C plus A. This would have to be B and B. Let's just talk about what we're going to do on this one, because I want to make sure we talk about them all. So what are you asked to prove on this one? number 4.
If the diagonals of the trapezoid bisect each other.
So in terms of letters, what am I going to prove on my picture? The diagonals do what to each other?
Bisect each other.
The diagonals bisect each other. Oh. So midpoint of AC is the same as midpoint of BD. But didn't we say that that's how we could show the two things bisect each other? They share the same midpoint. So you're going to find this diagonal, and then we're going to find this diagonal, and to show that they have the same midpoint. That will be the same as showing that that piece equals that piece, and that that piece equals that piece. This one's a short one. Show that they share the same midpoint. Can I stop and move on to the next one and set it up? I just want to get a bunch of these set up. This one will be less writing than the first two. Show that they share the same midpoint. Okay, what's the next problem that I assign? 6. Prove that the lengths of the diagonals of a rectangle are equal. All right, so here we go. Let's get a rectangle drawn. So we are given rectangle ABCD. Let's label our rectangle. That's a really big part of this problem. So this would be 0, 0. This would be 0A, if I choose it to be. This would be B0. There's no one way to do this. I'm just making up letters. I like the beginning of the alphabet, if you haven't figured that out. Then this is BA. You don't want to make up new letters if you don't have to. So that vertex C would be BA. What are we asked to prove on this one? Are equal. So we're asked to prove that AC equals BD. How hard is that one, you think? You want to find that diagonal? Can you use the distance formula to find that diagonal? Yeah? Can you use the distance formula to find that diagonal? Yeah? Can you show that they're equal? You've proven it. Can I move on to the next one? We'll do it on time. Yep, let's move on to the next one. I want to get these set up for you. What's the next one? 7. Prove that the lengths of the diagonals of an isosceles trapezoid are equal. Lengths of an isosceles trapezoid. So we are given isosceles trapezoid ABCD. So what does my picture look like if it's an isosceles trapezoid? Well, I'm going to do this. Then we're going to have to figure out how to name these points. That's the battle, I think. A, B, C, D. There's my isosceles trapezoid. Let me help you label these. This one's 0, 0. I'll call that one A0 maybe. Maybe not. I don't know yet. I might be wrong on that. Let's name this. By the way, that's supposed to be flat. Let's call this one AB. So that means that distance is A, correct? If that distance is A, what if I call this one C0? Then what would I have to call this one? If that distance is A, that distance backwards has to be the same, doesn't it? So what would I have to call that? By the way, there's more than one way to set these up, but that would have to be called C minus A, and then the y coordinate is B. So what are we trying to prove on this one? On number 7. Prove that the lengths of the diagonals are equal. Oh, just like the last one. So you're asked to prove that this distance, you're asked to prove that B to D is equal to A to C. Distance formula. Okay, I'll let you set that one up. Next one is 10. Prove that the line segments joining midpoints of successive sides of a rectangle form a rhombus. I like this one. So here's what we're given. We are given rectangle ABCD. We're asked to prove, well, let's get our picture here a second. So there's my rectangle, ABCD. I'll let you guys do the ordered pair this time. But what are we asked to prove? We're also given midpoints. M, N, O, and P are midpoints of AB, BC, CD, and AD respectively. We're given those midpoints. So let's plot them. So I've been given a midpoint right here. I'm going to call that M. I've got a midpoint right here. That's N. I've got a midpoint right here. That's O. I've got a midpoint right here. That's P. Now remember what it means to be a midpoint, right? You have those pieces equal, etc. But we're asked to prove that if you connect them, what shape do you get on any rectangle? That's why we're doing this in general. It might be a skinny rectangle, it might be a long rectangle, might be a square, because that's a rectangle. So I want to prove that what? MN equals NO equals OP equals PM. You want to prove that all those distances are equal, right? If it's a rhombus, all four sides are equal in length. So you'll have to do the distance formula. Sorry, 4 times. I did not give you these ordered pairs, but you can get them. I'm just trying to get them set up for you so that you can do this. Then it won't be such a bad assignment. The hard part is drawing the picture and labeling it. And I didn't finish labeling it, but you can, yes or no? Your rectangle you can label, and then you can get the midpoints. Remember, your picture is part of your proof. Okay, last one. Is there one left?
Yep.
Let's set it up. Prove that the diagonals of a rhombus are perpendicular. So I'm pausing a second because I'm not sure how I'm going to draw it. So we're given rhombus, A, B, C, D, and then we're supposed to prove, we'll get a picture here. So how do I draw a rhombus? I mean, I know how to draw it, but I don't know how to label it. That one would be 0, 0. All the sides have to be equal in length. I'm not giving you all the answers because Bill just ready, but we got to think about how we're going to label that, and then you're going to do what? That's the hard part, is how you're going to label it. The easy part, I don't know the easy part, but prove that they are perpendicular. So what you're going to do is you're going to find the slope of this one, you're going to find the slope of this one, and you're going to show that they are opposite reciprocals. Then when you multiply them, you get -1. I haven't given you all the answers to number 12, so you guys got a little bit of a challenge. How are you going to label it if it's a rhombus? Have a great weekend. Hopefully that doesn't take you too long to finish up.